In this problem, we are asked to find the area of the surface generated by rotating the curve y equals e to the x from 0 to 1, rotated around the x-axis. So the first thing is I will be using the surface area from a to b, 2 pi, the function f of x times the square root of 1 plus the derivative of the function with respect to x squared dx. So the first thing I'm going to do is I am going to take my function, which is y equals e to the x, take the derivative of that function with respect to x. So I would have dy over dx is equal e to the x. Now square that function. Dy over dx squared gives you ex squared. So the surface area from, I'm going to pull out the 2 pi out because it's a constant. So 2 pi from 0 to 1, my function f of x, which is e to the x, times the square root of 1 plus e to the x squared dx. So now right here, I am gonna use the u substitution in order for me to be able to integrate this integral. So my u is equal e to the x. The reason I let my u equal e to the x because I have an e to the x outside of the function of the square root, meaning if I do my du, if I take the derivative of u, I have my derivative inside of the function. So now replacing what I have, 2 pi, the integral from 0 to 1, I would have the square root of 1 plus u squared du. So now moving on right here, we're going to use also the trig substitution, u equal tan of theta, in order for me to integrate the surface area. Now, if u is equal to tan of theta, du is going to equal to secant squared of theta d theta. So now doing some math on the side, the square root of 1 plus u squared is the square root of 1 plus tan squared theta, which is equal to the square root of secant squared theta, which equals to secant of theta. So now after I have all of that, now I can rewrite my integral. The surface area from 0 to 1. I need to write the 2 pi outside. So 2 pi from 0 to 1. Now the square root of 1 plus u squared du would become s equals 2 pi from 0 to 1 secant of theta. Now du is equal to secant squared of theta d theta. So now here we would have the surface area of 2 pi from 0 to 1 secant cubed of 2 theta. Now using the integration table right here, the integration table, we know that secant cube, the integral of secant cube is equal to 2 pi times 1/2 secant of theta tan of theta plus ln of secant theta plus tan theta. And now here I need to set my integrals. So now here, since I have my integrals, I need to go back and put my integrals in terms of theta. I cannot leave my integrals from 0 to 1 because from 0 to 1, they represent the x values. And here it's easier just to switch my integrals into the theta. So now here I am gonna go and do some side work. So u is equal to tan of theta, which we already have. And now we know that u is substituted for e to the x. So now I have to go back to e to the x. Now from here, I am going to find when x is equal to 0, what is my theta? So I input x to be 0, so e to the 0 is equal to tan theta. So now here 1 is equal to tan theta. And then using the unit circle would get theta is equal to pi over 4. So now that's when x is equal to 0. So when x is equal to 1, I would have e to the 1 equals tan of theta. So now here, theta is equal to tan inverse of e. So after I have my integrals right now, my new integrals, I am going to set the conditions. So now here, it's going to be from pi over 4 to tan inverse of e. So now I input my conditions. So now 2 pi is equal 2 times 1/2 secant. Now it's easier to just set this equal to alpha, so I don't keep on writing tan inverse of e. So now here it's going to be alpha tan of alpha plus ln secant of alpha plus tan alpha minus, now here I'm just going to open a parenthesis so I don't have to rewrite the 1/2, minus secant of pi over 4 tan of pi over 4 plus ln secant of pi over 4 tan of pi over 4. Now here, this part right here, it's easy to evaluate, and that would equal to the 2 pi times, I'm going to factor out the 1/2 from here, so then I would have pi secant of alpha tan alpha ln of secant alpha plus tan alpha. Now secant of pi over 4 is square root of 2, so that's minus square root of 2. And we have the tan of pi over 4 is 1, so that's going to be multiplied by 1, plus ln of the square root of 2 plus 1. So now after I have that done, I need to go back and evaluate my alpha. So here I know that I set tan inverse of e equal to alpha. And from here I know that this is equal to e equal tan of alpha. So now from here I have the secant square of alpha is equal to 1 plus tan squared of alpha. Now inputting this what I have, so now I know that tan of alpha is equal to e, so I can replace that to be 1 plus e squared. Now this one, it's easier to solve. So now from here I have secant square of alpha is equal to 1 plus e squared. Square rooting both sides gives you secant of alpha is equal to the square root of 1 plus e squared. So now here I have pi times secant of alpha, which is the square root of 1 plus e squared, times tan of alpha, which is e, plus ln secant of alpha, which is the square root of 1 plus e squared, plus tan of alpha, which is e, minus the square root of 2 plus ln of square root of 2 plus 1. And that would be my final answer.